Hi everybody, this is Eugene O'Loughlin, lecturer in computing at the National College of Ireland, and welcome to my series of problem-solving techniques videos. In video number 16, we're going to take a look at PERT analysis. So first off, what do the letters PERT stand for? Well, they stand for Program, Evaluation, Review, Technique, PERT for short. Sometimes Gantt charts and project network diagrams are referred to as PERT charts and diagrams, but here we're going to look at this as a project time management technique. PERT uses probabilistic time estimates, and it's done when we have a high degree of uncertainty over the duration of a particular task. So for example, we may well have an optimistic time that a task will be completed within, a more likely time, or even a pessimistic time. So what value, what duration should we put on tasks where we have three time estimates like this? In order to do this, we need to calculate what's called the PERT weighted average, and this is the figure that takes into account the most optimistic time, the most likely time, and the pessimistic time in a formula that you see here. So OT for optimistic time, plus 4 times the most likely time, plus the pessimistic time, and divide that all by 6. Remember here that multiplication takes precedence over addition, so the bit in the middle, the 4 multiplied by the most likely time, is calculated first, and then you just add 3 values at the top and divide them by 6, and that will give you a PERT weighted average, which will be a single figure that you can use to represent the duration of the task when there is uncertainty with optimistic, most likely, and pessimistic time estimates. So let's take a look at an example. Let's say we have a task called task X, and we've worked out that all going well, the most optimistic time that this task can be completed within is 20 days. We figure from experience perhaps that the most likely time that this task will take is 30 days. And if things start to go wrong, the most pessimistic time could well be up to 60 days. Now normally we would put the most likely time, 30 days, down on our Gantt chart or on our project schedule. But we want to take into account the optimistic time and the pessimistic time as well. So what we want to do is we're going to apply the PERT weighted average formula using these data here. So let's see how that works out. So we take the optimistic time of 20, we add that then to 4 times the most likely time, which is 30, and then add the pessimistic time, which is 60, divide it all by 6, and that gives us a total PERT weighted average figure of 33.3 days. So what these figures are telling me here is that the most likely time of 30 days is not accurate enough because of the degree of uncertainty. So taking into account the optimistic time and the pessimistic time, the most likely figure, the best figure that we should put on our project schedule is 33.3 days for task X. So in summary then, if we take into account the optimistic, most likely, and pessimistic time using our PERT weighted average, the actual value that we would use is not the most likely time, not the optimistic time, nor even the pessimistic time, but we would put down 33.3 days in this particular example on our project schedule. I hope you found this technique useful. If you are interested in this and other problem-solving techniques, please check out my new book, An Introduction to Business Systems Analysis. It's available on Amazon. I hope you enjoyed the video. Thank you for your attention.